But we're going to use trapezoid rule to approximate this. Why? Because that's what the directions said. So, in order to do this, you kind of need to start with understanding where's your A and where's your B. Okay? So if I look at this problem, what's A? 0. So I know I'm going to have to plug in. So I'm just going to kind of highlight my X values that I'm plugging in. So X is going to be 0. I'm going to start with 0. And then what's my N value going to be? Pi, right? Now the question is, how many values are being doubled up twice? So this is kind of hard, but like, let's look right here. There's not 4. There's 4 trapezoids I'm creating. I have a start, I have an end. There's actually 3. Okay. So one thing I want to go back to, we're going to have A here. We're going to have B at the end, right? And here, this is always equal to n minus 1. You should have n minus 1 items that you're adding in there. So if I look at my n, what is n equal to here? 4. What's n minus 1? 3. So that means I need 3 different items in here. So let's look. If I look at this, b minus a over n, what's b minus a? It's going to be pi, right? Pi over 4 is still pi over 4. So I'm adding a pi over 4 every single time. So kind of look at how this turns out. I'm getting pi over 4 here. If I add another pi over 4, that happens to be pi over 2. If I add another pi over 4, that happens to be 3 pi over 4. And if I add another pi over 4, that gets me back to pi. Okay? There's my A, there's my B. N minus 1 says I have to have 3 in here. They're all equal amounts. Okay? So, what I'm going to do now is I'm just going to follow this formula. So, if they want me to use the trapezoid rule, my B value is pi, my A value is 0, all over 2 times n because of that 1/2 in the trapezoid formula. So, I need to do sine of, what's my A value? 0, plus 2 sine of pi over 4, 2 sine of pi over 2, 2 sine of 3 pi over 4, and lastly, plus single, right? There's only one sine of pi because this is my B value. Okay? The reason I do this is to help me understand what I'm plugging in there. It'll get easier as we go through it. Okay, so now we just do the math. This ends up being pi over 8. What's sine of 0? 0. What is sine of pi over 4? Radical 2 over 2, but I'm multiplying it by 2, so it just ends up being radical 2. Sine of pi over 2 is amazing because it's 1 times 2 is 2. Sine of 3 pi over 4. No, it's y value. So it's just rad 2 over 2. The 2's will cancel and you just end up with radical 2. And sine of pi is 0. Okay. Do you guys have any questions on how I simplified any of that? Okay. Going back, we could clean it up one more time. This ends up being 2 rad 2 plus 2. But see how the 2's and the 8 have a common? Is that too much? Okay. Everything here has a factor of 2, so it really would simplify to pi times radical 2 plus 1 all over 4. Okay? But that's the perfect answer too. You could leave it. I accept that. Okay? You guys okay? So now that we started off with a hard problem, let's kick it back to an easier problem. Okay? So let's look at example 2. So again, we're going to use trapezoid rule. I'm just not going to write it down. 0 to 2, my function is radical 1 plus x cubed. And I'm going to tell you that n is equal to 4. So guys, do we know how to even integrate that? We would maybe if there was like an x squared hanging out on the outside. Yeah, there's no x squared on the outside.
Wait, the x is still there, right?
Sure. Okay. See how there's no x squared hanging on the outside? We couldn't use u substitution here. Therefore, if we can't use u substitution, this one does not simplify. We actually don't know how to integrate that. Your calculator does, like if you wanted to plug it in, but we don't. So we're going to use a trapezoidal approximation. Okay? So let's kind of start. Let's just pick out our x values that we're going to have to plug in. So let's start with our a. What's our a value? 0. So that's what we're starting with. What are we going to end with? 2. Okay. What's our n say? 3. No?
Well, there has to be 3 values.
There has to be 3 values in the middle, but our n is 4, right? So I need 3 values because this is always n minus 1. So if I look at this, 2 minus 0 all over 4 is equal to 1/2. So that means every time as I start with 0, I'm going up by half. Okay? So this is going to be 1/2. The next value is going to be 1. Then it's going to be 3/2. This tells me what I'm plugging into my function. Okay. All right, so let's go and use that rule. So it says b minus a, so 2 minus 0 all over 2 times your n. So far, so good. Times, I'm going to plug in 0. So I'm going to get 1 plus 0 there, radical 1 plus 0, plus 2 radical 1 plus, what's 1/2 to the 3rd power? 1/8. So I'm going to put 1/8 here. Okay, just so you guys can kind of see what I'm doing. Yeah, plus 2 radical 1 plus, what's 1 to the 3rd power? 1. Plus 2, 1 plus 3 to the 3rd is, I'm sorry, yeah, 27 over 8. That should have been 3/2, I misspoke. Plus, we're on our last one, so it's just a single. I don't need a 2 here. I get radical 1 plus 2 to the 3rd is 8. Kind of nice how that one worked out. Okay, so let's simplify what I can. 2 minus 0 all over 2 times 4 equals 2 over 8, 1 over 4. Square root of 1 plus 0 is just 1 plus, I'm going to make that into 2 radical 9 over 8. I'm just combining to have a common denominator. You guys okay? Plus 2 radical 2 plus 2 radical 35 over 8. And lastly, square root of 9 is 3. So this is a perfect answer. They probably want the decimal approximation. When we use a decimal approximation, we have to go to 3 places. You guys can round or truncate. Do you guys know what that means? You can cut it off, or you can round it up if it's a 5 or higher in the 4th decimal place. So if you guys plug this in your calculator, you get 3.283. Okay? But again, this happens to be a perfect answer as well. But I would double check it against your calculator. Okay? All right. 3rd example, and then we're going to talk about the bottom. Okay, and then we're going to talk about that bottom thing that you guys should have glued in. Yeah, because you're finding an area. A of x, sure. Or I wouldn't give it any label. I would just honestly have an equal sign. So, as you guys can't see this is example 3. Okay, we're going to be integrating 0 to 3 over 2. My function is 2x plus 1. You guys are going to say, why are we even doing this rule? Because I want to. Okay? Okay. So, yeah, it's 2x plus 1. So, guys, trapezoid rule is not meant to trick you. It's just honestly to see if you know a different way, like a Riemann sum or, you know, an upper or lower bound to understand area. Okay? So, as I look at this, let's just pick out our x values. What are we starting with? We're starting with 0. What are we ending with? 3 over 2. What's our n value? It's 3. So how many more values do I have to add in the middle? I have to add another 2 values. So I'm looking at a total of 4. You guys with me there? Okay. So I have to figure out how far away are these values from each other. So I'm going to do b minus a all over 3. And you guys might look at this and you're all like, Miss Seaman, you get 3 over 2 over 3. You're right. I do. But instead of dividing by this number, I can multiply by its what? Reciprocal. So this really means I have 3 over 2 times 1 over 3. And as we look at that, it is 1/2. Okay? So that means starting at my beginning, I can go up by 1/2 each time, and I should end up at 3/2. So 0 plus 1/2 is 1/2. Add another 1/2, I'll get 1. Add another 1/2, I'll get 3. 3 over 2. Okay? It's a nice way to double check to make sure that you're back where you belong. Okay? So, now we're just going to follow that rule. It says b minus a. 3 over 2 minus 0 all over 2 times our n. Don't forget that 2, guys. That's a slight difference. Okay? So what I'm going to do is I'm going to start with this. I'm going to plug it in. I'm just going to get 1 plus 2 times, I have 2 times 1/2 plus 1. You guys see what I'm doing there? Plus 2 times 1 plus 1. I'm just plugging them into my function. Plus this is going to be single. 2 times 3/2 plus 1. Okay. If you guys are wondering why I simplified this right away, just because it was 0. If I plug 0 in here, I'm just going to get 1. Okay? Okay, so guys, let's be a little bit smart. If over here I did b minus a over 3, and I got 1/2, what's 1/2 divided by 2? 1/4. You could do the math, but this is just going to end up being 1/4. Whatever this is over here, your leading value is half of that. So this is going to be 1/4. Okay? So I'm just going to do some math. What's half of 2? Plus 1. 2 times 2 is 4. Okay. 2 times 1 is 2 plus 1. 3 times 2, 6. 3/2 times 2 is 3, plus 1 is just 4. Remember, don't double it. That's the biggest mistake I see, is you guys like to double the last one for some reason. I see it happen a lot. Don't do it. Alright, so 1 plus 4 plus 6 plus 4 is 15 over, and we are done. Okay? All right. Now let's look at how you're actually probably going to see it on your AP test. This thing applied, okay? They're not going to be like, oh, use a trapezoidal approximation. They'll be like, no, just integrate that. Like, down here is where they're actually going to use a trapezoid sum. Okay? So, it says, a metal wire of length 8 centimeters is heated at one end. The table gives the temperature in degrees Celsius. The wire X centimeters from the heated end. Show your work and indicate units of measure for each problem. Okay. So guys, before we even start, What does x represent up here? Look at the unit. Centimeters. So what am I even talking about? What does this even mean? This is the what? If something is given in centimeters, it must be a length. Okay? This is the length of the wire. You need to understand that. Okay? It says T of x Celsius. What does this represent? The temperature of the wire at that certain point, at that length, right? Good morning. Not here. You find them? Good for you. Okay. Temperature of wire at certain point. Okay. So, here we go. Guys, there's a lot of interpretation. They say estimate T prime of 7. What does this mean in the context of the problem? What are the units? Okay, let's think about this. What is T prime? It is it's a derivative. What's another word for derivative? Slope. Rate. Okay? They are giving me a table. Do you see a 7 up here? No. But do you guys think you could estimate a slope at 7? How? Kind of. So guys, what? Okay, yeah. So guys, where would 7 fall on this table? Between 6 and 8, right? Heck, it falls between 0 and 8. But the question is, can we find 2 points that are exactly equidistant from 7? Yeah, 6 and 8. So what we're going to do is we're going to create what does that mean again? It means a slope. We're going to create a slope with these 2 points to figure out T prime of 7. Okay, no. How do we find slope? We use the slope formula, back in algebra. y2 minus y1 all over x2 minus x1. So let's look at what we're looking at. Here's what's T prime of 7. We're going to take T of 8 minus T of 6 all over 8 minus 6. This is y2. This is y1 all over x2 minus x1. This is just algebra. So now, let's do this. So what's T8? So 55, I'm even going to put degrees Celsius minus 62 degrees Celsius all over 8 minus 6. And what is this measured in? Centimeters. So let's just simplify this answer. What do we get? We get -2 over 7 Celsius per centimeter. Great, we found an answer, but now it says, I'm sorry, -7 over 2 Celsius over centimeters. What did I say?
You said -2 over 7.
I lied, -7 over 2. X that video, X that. Sorry, no. So guys, we have an answer, we have the units, but it says, what does this mean in the context of the problem? So let's go back. What does prime mean? Slope. What's another word for slope? Rate. So we're going to say the rate of change is what? -7 over 2 when x is 7. Okay? So, the rate of change, and don't say it's increasing or decreasing. Your signs will take care of that. You simply just need to say rate of change. If you guys say the rate of change is decreasing at -7 over 2, you've just done a double negative. Leave increasing, decreasing out of it. Just say the rate of change is -7 over 2 Celsius over centimeters when x is 7. Probably. Okay. Now, it says using the trapezoid rule in 4 subintervals include units. Now, something kind of tricky. All of our intervals have been equidistant. What does that mean?
Equidistant.
They've been the same width, right? Do you guys agree? They've all been the same width. Looking up at these numbers, do you guys see 4 different trapezoids I could create? Yeah. Are they equidistant? No. So what they're saying is use the area for trapezoid and calculate all these individually. Okay? So, you cannot use the trapezoid rule here in terms of how we were doing it because these points are not the same distance in between. You guys see it? Okay. So here's how you're going to do this. Let's remember, what's the area of a trapezoid? 1/2 times your height. So, looking at this, what's my height? From, like, we're looking the 0 to 1, 100 to 93. What's my height?
100.
Remember?
It's going to be 45.
No, remember, it's our trapezoid's flipped on its side. Look at the picture, guys. What's our height? It's flipped on the side. No. Look at your x values. What's the change in your x values? No, what's the change in it? 1, that's our height. Because look at how the trapezoids are on my picture. Do you guys see it? I told you we were flipping our trapezoids today. Yeah, exactly. So our height is actually measured by the width. Does that make sense? Okay. So we're going to have 1 times, I'm going to do what with these 2 numbers? We're going to, no, add them. Okay, so that's trapezoid 1. Trapezoid 2, 1/2. Okay, so what's our height, aka width? 100 plus 93? 100 plus 93. So what's our width in the next one? 4. And then we're going to add our 2 y values together, which will be 93 and 70. Plus 1/2. What's our width on the x-axis? 1. Our y values will be 70 and 62. And our last trapezoid will be 1/2 times 2, and then 62 plus 55. Okay. I'm going to save you guys some time in the calculator because you would be allowed to use a calculator here. It'd be 605.5. But, what are my units? So it's going to be Celsius times centimeters. Because if we're integrating, we're not dividing, we're multiplying. Okay?
Total area.
Yeah. So it's going to be degrees Celsius times centimeters. Okay. So, ladies and gentlemen, last thing, and this is going to come up on your review, and you're going to have questions on it, and that's okay. So, it says, find the average temperature of the wire using this. It says, include units. What am I looking for? What's my final answer unit going to be? If I'm looking for what? Exactly. I'm looking for temperature. My final answer has to be degrees Celsius. What's this? That's a definite integral using 0 to 8. But did they give me a function to actually integrate? What's the next best thing that I could have done is use what rule? Which I just did. Okay. They're asking you to do a definite integral from 0 to 8 of this function, but they don't give you a function, they give you a table. So what they're trying to say is use your previous answer to plug in here. Okay. You guys see what I'm saying here? So the question is, why is it 1/8? It's not how many values I have.
Centimeters.
That's how long the what is.
Wire.
The wire. Okay? So the wire is 8 centimeters, right? So let's denote it as such. They're talking about the average temperature. So 1/8 centimeters because that's the length of the wire. What was my answer from up above? 605.5. Let's put our units. Degrees Celsius times centimeters. What do you guys see? Centimeters canceled out. Okay. So now 605.5 divided by 8 is just equal to 75.68. You could put 7 or 8, but if you want to be exact, you put 75 because that's the way it works out, degrees Celsius, which means the average of the temperature at any point on that wire is 75.6875 degrees Celsius. Okay? So guys, don't blow off these problems on your homework. They're hard, but these are the ones that you're going to see on AP. Okay? So, I need to run down to the copy center. She has your copies ready, so I'm going to be right back.